X-rays. They're a superpower we can't live without. To see inside all the materials that are the building blocks of our modern-day lives.
Rigaku means science.
Scientists are dreamers, and we are developing the dream machines they are hoping for.
I paint with atoms to make mirrors for X-rays, and we're making products that make the world a better place.
Every customer is special, and we are trying to find solutions together.
I absolutely love what I do because it has a real impact on the lives of everyday people.
My father, Dr. Yoshihiro Shimura, was a pretty well-known X-ray crystallographer at the University of Tokyo. In December 1951, he set up his own company, a small garage operation developing and manufacturing X-ray diffractometer. 2 years later, he could come up with the first Japanese-made X-ray apparatus called the Gigaflex. Summer 1971. After my father passed away, I thought, if I am to take over this business, I must introduce something new to the company. What I can do, which my father could not do, was increasing our export to globalize this business. My father had pushed the business with China a little bit, but that was not good enough for me. I went to college in the US, MIT in Boston. I wanted to expand our business in North America. In 1971, just outside of Boston, I started out with one other guy in a very small office, and at that time I defined what I called the 4 strategic products for globalization. We have grown from just 2 domestic factories to facilities and offices on 6 continents, starting with the US and now all across Asia, Europe, South America, and the Middle East. Nowadays, 60% of our business is outside Japan.
Rigaku's cutting edge is complete solutions, analytical instrumentation, software, and customer support. The company provides the world's most versatile product range using X-ray techniques, handheld laser spectroscopy, thermal and gas analysis. Core components are X-ray sources, optics, and detectors manufactured in-house in Japan, the US, and Europe. In Tokyo, Rigaku headquarters has a large application laboratory, machining and assembly facilities. Here, traditional Japanese craftsmanship fuses with ultra-precise engineering and machining capability to manufacture parts used in X-ray sources and goniometers. Expert engineers check the micron precision using high-resolution cameras. Along with a spectacular view of Mount Fuji, Rigaku's Yamanashi factory boasts over 8,000 square meters for in-house production of standard products and most component parts. 1- and 2-dimensional X-ray detectors, the rotating anode and sealed tube X-ray sources, and high-precision goniometers, as well as much of the electronic circuitry, film capacitors, and injection-molded high-voltage power supplies. In-house quality control ensures perfection.
高電圧の回路の中で使われるキャパシタだったりとか、ダイオードもですね、特別に品質管理したものを使っています。安定した電圧を発生して安定した X 線を取り出すため、真空に引きながらインジェクションするような形でモールド剤がしっかり入り込んだり、中に気泡が生まれない我々の本当に誇れる技術だというふうに思っています。
Rigaku's goniometers are tuned to 1/10,000th of a degree, the highest possible precision. Detectors are produced in the clean room, the 1-dimensional DTEX, and 2-dimensional high-pix hybrid photon counting detectors, featuring flip-chip technology.
受光素子と読み出し英式を微小な時ハンダボール、インジウムバンプで直接つなげる技術のことをリップチップボンディングと呼んでいます。その実装した時の精度、ハイピックス3000なんかでいうとおおよそ30万ピクセル、30万個のバンプがついていますけども、それを1ミクロン以下の精度で ズレなく実装するという技術が我々の中で最新技術になっております。
理学の最先端って一言で言うと、それは信頼性だと思っています。社内で開発して社内で生産をしていくということが理学の重要な方針になっています。
Just 10 minutes drive up the road, partner company PNP assembles Rigaku's specialist semiconductor metrology instruments.
TXRF、MFM、TSAX などを製造しています。X 線のコア部品、X 線源、それから検出機を理学で作って、こちらで乾燥計とか筐体とか組み立てを行っています。アプリケーションエンジニアがお客様の納入先でも組み立て検査を行います。これによって製造時と納入時同じ品質を保つことができます。
We always go after the quality by continually acquiring companies with core technology, but also giving them the freedom to flourish independently. Rigaku Innovative Technologies is a good example.
RIT specializes in precision thin film multi-layer coating and optical engineering for lab instruments, synchrotron and neutron facilities, and EUV microlithography for making semiconductor chips.
Innovation is our hallmark. We pioneered XRF analyzer, one-dimensional multi-layer optics for XRD, and two-dimensional beam conditioning optics for single crystal. We're also using micro-focusing source. All those have become industry standards today.
I make multi-layered thin film coatings. I paint with atoms to make mirrors for X-rays. The individual layers are on the order of 3 to 100 atoms thick, but we do it with picoscale, precisions of 1 to 10 picometers, meaning sometimes as low as a 50th of an atomic diameter. So how do we do it? This is the inline Generation 2 magnetron sputtering system. We use a set of magnets and electric fields to create a plasma, and then the plasma creates ions that slam into a target material, causing those atoms to eject out and land on a substrate or an optic that you're trying to coat. It's ultra high vacuum, it's ultra clean, and it's ultra precise. We now have components in instruments that are as complex as anything the human race has ever made, and Rigaku Innovative Technologies is a part of that.
We have to go after synergy. Our core technologies are being continuously improved through global collaboration.
In single crystal X-ray diffractometers, there is one standout company. Now Rigaku Oxford Diffraction in Wrocław, Poland.
Here in Rigaku, we are completely free to develop and offer something new. We do what we love, and we love what we do.
Through collaboration with the team in Poland, Rigaku developed the Crystal Lab Synergy series, a world first in crystallography and bestseller.
We really are a success story about the synergy between our team and other companies in the Rigaku group. Our core technology sits in the goniometer, and our expert technicians hand assemble the parts and then calibrate them. Pavel here is assembling the gears, worm gears, stepper motors, and optical encoders for the omega and theta axes of the goniometer.
Proprietary software drives the Crystal Lab Synergy instrumentation, interprets the complex diffraction data, and solves crystal structures.
Successful instrumentation is an interplay between hardware and software. That's the key for the cutting-edge technology, and it's a constant evolution. So what we do here is user-inspired. It's a two-way dialogue between our customers and Rigaku, scientists, engineers. Automation allows users to use the machine in an interactive fashion. The experiments are run in minutes and not in hours.
Others need mobile devices to take their lab to the field.
Rigaku Analytical Devices is a pioneer in handheld technology. Our cutting edge is mobility to give our customers the right answer on site very quickly. So what's really important to our business is our capability to develop purposely engineered optics and that includes spectrometers, but also lasers. And we manufacture those here in our facility. Both our handheld ramen and our handheld lib systems have won R&D 100 awards. We're really proud to have had the first handheld 1064 ramen on the market. 1064 nanometer excitation reduces fluorescence and gives a ton of incremental capability in terms of identification of chemicals and hazards.
Our people are the real assets. You need experience, the scientific expertise, and foresight. Our mission is to contribute to the enhancement of humanity through scientific and technological development.
They study the structure of matter at the atomic level.
In single crystal X-ray diffraction, we determine new structures every day. With the crystalline sponge method, you can impose order on small molecules so their structure can be determined.
We're not just selling instruments, we're selling the answers to scientific problems.
We developed the world's first high-resolution microbeam XRD instrument. This is helping our semiconductor customers all over the world.
This is a new type of solid-state battery attachment.
Everyone experiences Internet of Things. New devices must be more powerful. We are using Rigaku instruments to provide good characterization of semiconductors.
I use the sequential wavelength dispersive XRF spectrometers to fingerprint all the alternative fuels and raw materials that are used in the cement manufacturing process.
We have a wonderful support staff that has a sense of urgency and professionalism.
Many are touched by the innovation that Rigaku creates.
理学の装置がなければ研究ができない。理学の装置がなければ材料開発できない。こういったお客様はいっぱいいらっしゃるんですね。
How do I describe the relationship between our university and Rigaku? One word is reliable. They give me the solution. We can solve the problem for us.
Rigaku means science.